This is part one of today's lesson on the quadratic formula. So before we start in with the quadratic formula, we're just going to do a quick recap of what we learned the other day about radicals. So radicals are just roots, like square roots, and there are other types of roots that we will be talking about later on in the course. So when you are adding and subtracting different square roots, what we want to do is try to find the like terms. So like terms are the things that have the same number under the square root. So 5 root 7 and 8 root 7 would be considered like terms. So when we're adding the like terms, we're going to add the coefficients, and then the roots are just going to stay the same. It's a lot like working with a 5x and an 8x, except this time instead of an x, there's a square root of 7. So 5 plus 8 is 13. So we have 13 root 7ths. And then I have a 9 root 37 and a minus 4 root 37. So since they have the same number under the square root, I can combine those to get 9 minus 4, which is 5, times the square root of 37. Now, I cannot simplify that any further because the roots are not the same, so that would be my final answer right there. The next question has some multiplication and division, and as we discussed before, when we're multiplying and dividing roots, we multiply and divide the coefficients, and then we multiply and divide the numbers underneath the square root sign. So we're going to start with the numerator, and I'm going to start by multiplying 3 root 12 by 10 root 5. So first we're going to multiply the coefficients, so 3 times 10 is 30. And then we do the numbers underneath the square root, so 12 times 5 is 60. So I end up with 30 root 60 in the numerator. And in the denominator, we're going to leave that 6 root 10 for the next step. And now I'm just going to divide, so coefficient with coefficient, root with root. 30 divided by 6 is 5, and 60 divided by 10 is 6. So our final answer will be 5 root 6. Now we have one more that we did the other day, and that is what we do when we have brackets. So I have 2 root 15 plus the square root of 8 times 5 root 3 plus 6. So to multiply out two brackets, we're just going to FOIL them out. So remember, FOIL stands for first, outside, inside, last. So we're going to multiply the first in each bracket, and we do the same thing. We're going to multiply coefficients, and then we're going to multiply the roots. So 2 times 5 is 10. 15 times 3 is 45, so I get 10 root 45. Then we do our outsides. So 2 root 15 times 6. Now I notice there's no root part here, so I just do the coefficients. So 2 times 6 is 12, positive 12. And since this doesn't have a root, it's just going to be the square root of 15. Then we do our insides. So the square root of 8 times 5 root 3. Now that would really be a 1 times the square root of 8. So 1 times 5 is 5. And the square root of 8 times the square root of 3, that's going to give us the square root of 24. And then our last one, we do the last term in each bracket. So that's going to be the square root of 8 times 6. And since one's a coefficient and one's a root, we're just going to end up with 6 root 8. And then if I want to collect up my like terms, I notice that I don't really have any terms in the square roots that are the same. I also check to see if any of them would work out nicely on my calculator, which they would not. So for now, we're just going to leave our answer as 10 root 45 plus 12 root 15 plus 5 root 24 plus 6 root 8. Now the new part to this today is about mixed radicals. So we talked about mixed radicals. We said that a mixed radical is a part that has a coefficient, like 2, and a root part, so say 2 root 7. So what we want to do is we want to try to figure out how to turn some of these into mixed radicals if we can. So I'm going to start with the square root of 32. To make a mixed radical, what you want to see is if there's a perfect square that divides into 32. So a perfect square would be numbers like 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, which is 64, 9 squared, which is 81, 10 squared, which is 100, 11 squared is 121, 12 squared is 144, and we can keep going, but I think for now we're just going to leave it at that. So you want to try to find one of these numbers that would divide into 32, and you want to try to find the biggest number that would divide into 32. So I can see obviously 36 is too big. 25, if I try, does not work. 32 divided by 16 is actually 2 when I try it on my calculator. So 32 I can write is the same thing as the square root of 16 times the square root of 2. I used a little dot there for multiplication. You can use a dot, you can use your multiplication sign, or you can use brackets. So once I found a perfect square, I write down what I need to multiply it by to get 32, and then I'm going to work out anything that works out nicely here. So the square root of 16 is actually 4, and then the square root of 2 is not a very nice number, it's a long decimal, so I'm going to leave it as 4 root 2. So we're going to try one more. This one's actually already a mixed radical, but I want to see if there's anything I can do with that 175. So when I take a look at my list, obviously I need a number smaller than 175, but I do notice that it ends in a 5, which means it should be divisible by something with a 5. So 25 is 5 squared, so I'm going to see what 175 divided by 25 is. And I get 7. So I'm going to say here that this is the same as 2 times the square root of 25 times the square root of 7, because 25 times 7 equals 175. And then I'm going to work out any of the square roots that work out nicely. The 2 is still just a 2. The square root of 25 is 5. So I'm going to write that that's 5. And the square root of 7 is not a very nice number, so I'm going to leave that as the square root of 7. Now this is all multiplication, so I'm going to multiply 2 times 5 to get 10 times the square root of 7. Now why would I want to do this? That's the big question of the day. It is going to help us with the quadratic formula, but we're going to try one more question here to see if we can find a reason why I might want to use mixed radicals. I have the square root of 45 plus the square root of 500 minus the square root of 245. And we've talked about the fact that in order to add and subtract, you need to have the same numbers under the square root. And right now, these do not have the same numbers under the square root. So what I'm going to do is see if I write them as mixed radicals, whether I end up with the same number under the square root. So I'm going to look for the largest perfect square that divides into each of those. So 45 is definitely something that's divisible by 5, but 25 does not go into 45. 45 is actually 9 times 5. So I'm going to say this is the square root of 9 times the square root of 5. 500, I notice, is definitely going to be divisible by 100. It's got the 2 zeros. So this is the square root of 100 times the square root of 5. And then 245, well, is that divisible by 25? Nope. Has to be divisible by something. So if you're stuck and you don't know, then what you can do is you can just start working your way through the numbers and see what you get. So 245, we could try 81. That didn't work. 245. I don't think it's going to be divisible by 64 because it's not an even number. So maybe I might try 49 if I work my way down the list. Ah, look at that. We get the square root of 49 times the square root of 5. Something else you can try is, since you notice that this has a square root of 5 and this one has a square root of 5, you could have tried dividing this by 5 to see if maybe this was going to be work out to be something that ended up with a root 5. So I'm going to work out all the different roots. I've got the square root of 9, which is 3, and the square root of 5 is not a very nice number. The square root of 100 is 10, and there's that square root of 5 again. And the square root of 49 is 7, root 5. So since they all now have a square root of 5, I can just add and subtract the coefficients. So 3 plus 10 is 13, and 13 take away 7 is going to leave me with 6, root 5. So in part 2, we'll talk a little bit more about the quadratic formula. See you soon.